like 1D we have done, 2D we have done, 3D we have done. Okay, the remaining are like that only. Okay, this one also lies on what we have to make this two portions fix the support, and here we have to specify the pressure of wait a second guys. Yeah, now see here in this problem nothing is there. Here we have to specify two holes for this location. We have to specify fixed support, and here we have to specify the pressure. What we have to find the total deformation on bracket design. It's not bracket, it's a bracket design with the following data as shown in the figure. 4 holes on its corner fixed to the wall, load 1200 psi acting on its top base. Identify whether bracket can able to bear the load or not, and able also find the what is that, normal stress along load direction. See here guys, till now we have done so many analyses, but in none of the analysis we have read the results. Just we are checking this much stress we are getting, this much deformation we are getting, that much only we are seeing. Deformation also like we are getting by 0.01, but actually we are not able to think, or we are not able to find whether this object is passed or failed. Okay, whether the object is passed or failed, whether the object is getting failure or not, we are not discussing about that thing. Just we are solving our problem. That's it. Today what we will do, we will check on this problem whether the object is passing or failing. Okay. What I will do, I will create this component under KDA. Why? Because I am looking like it's a big component. So it is difficult to create in close this one, go for part design. How the figure is 85, 80, 150. Okay, 80, 150. Yeah, fine. 150, and this is like thickness. It's mentioned as 5 mm. Go for pad. 5 MB thickness. Okay. Now I will create sketch on this plane. Then this 0.5 thickness. Okay, 70. Okay, done. I will create this figure here. Project this curve. Vertical. Okay. Frame. Okay. Now specify the dimensions from here to here as 70, and from here to here it's mentioned like 25. Then that is also 70. Selected there. This is also 70. This is 2.5. Exit Workbench. Make pad here. Ruler extend 35. Okay, go for shell. Remove this face. Thickness as 2.5. Wait a second. Create one line. That is like 2.5. Go for shell. Okay, this is my body, and here on this face I have some holes. I will create those things. Actually, these things we have to create before and here I'm making this things like hole is radius 3, diameter will become 6. The distance from here to here it's mentioned like 10, 10. And distance from here to here is 10. Copy this one, make mirror on this side, copy this too, make mirror at the bottom side, exit, pocket, okay, file, save as, stop, file, okay, save. Now go for static structural. Go for engineering data. Why? Because we have to change the data here. Data, it's mentioned anything? No, it didn't mention anything here. Just we'll take a static structural steel. Go for importing the geometry model. File, import external geometry. Problem file. The problem will not solve problem. I've taken problem here, problem file. I will check, wait a second. File, import external geometry. If I take, I have saved in a KTR file format. So it's better to go once again, file, save as. I have to save this one STP format. Problem file, save. Okay. Now go to design modeler, file, import external geometry, problem file, okay, generate. And make this one like add method. Okay. Now this is our geometry here. I have to assign the boundary condition for this geometry. So for model, have to assign the check the material kind or not. It's assigned here, then coordinate system, mesh, generate the mesh here. So we generate the mesh, then we'll check what kind of mesh we required. We require some smooth mesh here. It is somewhat better. I will increase this one to medium. Because if I take the fine means it will create more material and take some more time here to solve. Now it's looking somewhat better mesh. Now go for assigning boundary condition. Right click insert. Fix the support I want in these holes. Apply. Now see here the fixed support assigned here. The next thing we have to specify here is pressure on this space, that is 1200 psi. To change the unit system to US customary, then go for assigning the pressure on this top face. Apply how much you require, 1200 psi. Okay, that much pressure we have to specify it there. Now we have to check the results here. Then we will find whether the object is bearing that much load or not. So go for solution set. What are the things we have to find? We have to find total deformation and normal stress also we have to find here. So right click, insert total deformation, right click, insert stress, normal stress. Okay, around I want on Z axis. Okay, so why? Because we are assigning the pressure in Z axis now. So we have to take the normal stress in Z axis. Now see here. Right. Normal stress we are getting around, I will go for megapascal, 4080 megapascal. Okay, 4080 megapascal stress. We will check, this is your normal stress. Now I am checking here equivalent stress, how much we are getting. Equivalent stress I am getting here 5881 megapascal. That much stress I am getting here. Now the question arises. See, till now whatever we are saying, that is our result, that's it. Like we are getting this much stress, this much. How to identify whether this thing is satisfied with our results or not? Whether this object is success after creating, after manufacturing, whether it may bear that much load or not, we have to check here. That is the reason we are performing the analysis. So how to identify this? So see here, for identifying this thing, we have to go for load. Then we have to go for bottom side to check the results. Where is my result? Model is here. These are stored to material data is there here. Like the material, whatever we have taken is the data. Where is that result? Yes. See here we have equivalent stress. Maximum equivalent stress I am getting like here the equivalent stress I am getting, the maximum equivalent stress I am getting here is 5881.2 megapascal. Okay, that is my maximum stress. Deformation I am getting 5.743. Okay, 5.743 means it's a very big one actually. But whether that much deformation will happen to that object or not, we have to check. Why? Because every metal will break at certain point. After some deformation, after that elastic limit, after that deformation, the object will get break. Okay. So maximum stress, how to find that one, whether the object is bearing that much load or not, means by seeing this value. Like I am getting 5881.2. Guys, you already know about the stress strain curve. Okay, stress strain curve is there. We have some points are there. I will show you that one. What are the things are there? Yeah. Now see here, this is my stress strain curve. So this one up to the point, so see from point A to point B, we can say as a proportional limit. This one we can say as a elastic limit from B to C. C to D we can say as a plastic limit. And this D we can say as a yield point. Upper yield point, and T we can say as a lower yield point. Okay, and here we have the ultimate stress point. Okay, here we have ultimate stress point, and here we have breaking or fracture point. Okay, this is my stress curve. But how, at what stress we are, for example, if we have a material like structural steel, for that steel, we have to check what is my yield point and what is my ultimate stress point. Okay, what is my ultimate? Why? Because from this ultimate stress point, the object is going to break from here. Like fracture is there from this point only. So that stress value we have to check. Now see here, I am going to the report. I got the stress value like 5881 means 5881.2 megapascal stress value we are getting here. Now we will check here. Why? Because I already taken that values from the material. Now see here. Here I can find here yield point. So we are specifying the compressive force there. So in that case, we are getting here compressive yield strength. The maximum is 250 means the point that these values will remain constant. So if you are getting value till 250, if I get means that one also we can say somewhat safe only. But the actual thing is, if you are getting the values one third or one third only, usually one third of this 250 value, then only we can say that that material is safe. If it is exceeding one third limit, then also we can say that our object is a failure. Okay, our object is failure. One third limit. But right now we are getting the value like 5881.2 megapascal, which is very much bigger than your yield point. Okay, which is very much bigger than the yield point. Means it is crossing the limit, like it is becoming nearly 20 times bigger than that yield point. Might be we will check the ultimate strength. Ultimate strength also like 460 only. Ultimate strength is also like 460 only. Like ultimate strength is this one. From this point the object is going to break. From this point the object is going to break, and this point also it is mentioned like 460 only. But we are getting the value 5000. So that much pressure that object will not bear. So whatever material you have taken, that is failure. Might be the material is failure, or the pressure whatever you are specifying that is very more, or else the design whatever you made definitely it is going to fail under that pressure. Means either you have to optimize your body, okay, either you have to optimize your body, or else you have to take a material which is more stronger than the structural steel, okay, or we have to reduce the pressure. Usually pressure will not get reduced. Why? Because we are considering that much pressure only, okay, we require that much pressure. Why? Because when we are creating any component, first of all we will think how much load we can, like how much load it is getting there. First thing only we will check that one. So anyhow we require 1200 psi pressure, definitely we require that. So but that is the reason we have to think. So pressure we cannot able to change. Only thing we can change is our model. Usually material also we can change. But sometimes what happens, if I change the material, some other property will get affected. So due to which sometimes material also like that only. So what we have to do, we have to change the model only. So what we can able to do here, we can increase the thicknesses. Here we have the feature shall I increase move face? Remove this face. Complete. Okay, replace face. Cancel. Replace face. Replace face. Or do one thing, just to go for remove face, remove this face first. Yeah. Then we have any option to make this body somewhat. So what I will do, I will increase the thickness. Okay. These things are I will make like 5. This becomes like 5. Okay. This one I'm making like 10. Okay, let's see. Go for remove this. Delete this one once again, make a remove this. What's happening here? What is this here? It is becoming somewhat hollow here. Instead of shell, what I will do, I will make pocket here. So like that only, guys, we are doing the optimization work. Pocket. This channel I am somewhat changing here. Okay, somewhat I am increasing the thicknesses here so that it can bear the pressures. Now come to the model, not model, go for here. Right click here and change the material. So change the object. Right click. Here you can find replace geometry, browse, take problem 6, open. Now double click on model environment. Yes, I want to update the data. Go for geometry. Now once again click on sort. It is throwing some error here. Geometry is there only, you have this support that is not accepted to any geometry. Fixed support I will change once again. Why? Because this thing will get damaged. Why? Because initial thickness is different. Reduce. Now change the pressure and apply on this space. Apply. This is megapascal. Once I will check how it is going. Yeah, that's fine only. Now click on solve. Now check the total deformation here. We change the model. It is coming like 0.028247. Normal stress I am getting, still I am getting very, no. You can this one to megapascal. This one also very big. That is 1104. Wait a second, guys. Yeah. Now see here, guys. This pressure is also very more. Why? Because here also we are getting a very big stress value, which it is not okay for our object. Like here also we required. See, anyhow, it should not cross this limit. Okay, it should not cross this limit 250. It should not cross this 250 limit. But here I am getting 1104.9. Understand, guys? Understand?
Yes, sir.
Any doubt? And you understand how to optimize the thing? Like that, we'll modify the object by checking the results. Even we can able to do here also by going into design model. This is my model. Usually I will do on modeling software only optimization here. Here somewhat we can face create I will do I will do once again optimization here. We will check till we will get the proper results. Translate. Delete. Change the units to mm. Create body transformation. Translate. I want to not translate. I think we cannot able to do body of Transformation. It is somewhat difficult, guys. Here, those modifications, optimization work. What I will do, I will check somewhere else. Here we have one more option here, that is space claim. There also we can able to do the work optimization. Let's see there is how it is. Yeah, came here. So here we have to do some optimization. Go for repair. Design. Pull the faces. I want to increase some 2.5. 2.5. 2.5. Okay, I still increase some more thing here. Now minimize this thing. Go for model. Yes. Text. Don't need to update the mesh. Go for safety support. Once again, we have to select the faces. Why? Because it has been changed here. Apply pressure I want on this top face. Click on solve. Now check the total deformation. It is like 0.016836. Normal stress in PSI, I am getting that much. I want in megapascal. Somewhat reduced here, but still it is not satisfying. So what we have to do, we have to change the material once, then we will check whether it's coming or not. Okay, so go for engineering data. What is here? Concrete, copper alloy, also less, grey cast iron also less, magnesium alloy also less. polyethylene outside there, silicon, stainless steel outside there, structural steel is more dependent upon every material is less only here. So the design is completely failure. So that much pressure is not possible to make any compound. That much pressure it will not bear anyhow. I because see here whatever materials I am taking, the Young's modulus is less than structural steel. Structural steel is 2.1 into 10 to the power of 11. When I am taking all the remaining materials, and when I am taking the remaining all materials, the Young's modulus value is less than 30 only. For example, if I change the Poisson's ratio for this one, just check what happens. Poisson's ratio is changed to 0.33, and this Young's modulus value how much again I gave 2.1 now, 3.1 e to the power of 11. I will just check how much, whether it is possible to bear or not. Okay, for the structural steel only, let me set it as 3.12. Equivalence plus 780. Still it's not coming. So the model whatever we created here now is completely a failure. It's breaking from somewhere here now. Not somewhat strength, but here it is breaking now. So like that, we have to check the results, we have to optimize the objects based on our requirement. But this requirement is not all possible. Or else what we have to do means we have to find the material which has better strength than structural. Aluminium is made of load or not. Here also we are getting 781.5 here. And normal stress I am getting. So these values here we can say as a design failure. Why? Because that load is not at all getting. We can do one more thing here. What can we do? I will do some modifications. If I remove this pocket, what happens? Let's see. Okay. I will remove this pocket. I will keep like that. If I keep like that, let's see what is going to happen. File, save as, STP format, 7. Go here, change the design modular, close this space plane, right click, replace geometry, browse, go for 7, open, double click on model. Yes, I want to update the things. Now take the support, these things, Here guys, here what we have to do, individually we have to select the, see single hole is there but we select two faces. I will show one option to you. If you do that option means it will become like a single face only. Okay. Pressure I want to specify here. Apply. Solve. Still it's not coming guys. Anyhow it's getting big. So this is your design phase. Yes. You cannot able to update any more now. Understand guys?
Yes, sir.
Any doubt?
No, sir.
Now the next thing is, guys do one thing, join once again to the meeting. Why? Because 1 hour is done. Anyhow the meeting is going to close in 2 minutes. We will join. You guys join once again.